Hello guys, welcome back to Clinically Clear. So today let's cover some few important 3 mark topics in genetics. First of all, what is eugenics versus euthenics? See, eugenics is improving the human race by increasing gene quality. Basically, we're manipulating the genetics and then we're improving the human race. Basically, you can think of what Hitler did as eugenics. That is, he selected one population that he perceived to be of good gene quality, and he tried to improve the human race by increasing that gene quality. Basically, you can have two types of eugenics. You can have positive eugenics and negative eugenics. Positive eugenics basically, wherever you have good genes, you will increase the good genes by increasing reproduction in that population. Negative eugenics is wherever you have bad genes, you will decrease the frequency of bad genes by decreasing reproduction in that population. And eugenics, the effects on progeny is extremely visible and prominent. Okay, this is about eugenics. It's everything to do with gene manipulation. Genetics are manipulated and we're trying to improve the gene quality. Whereas euthenics is environmental manipulation. We are enabling gene expression by improving the environment. So we are manipulating the environment. But euthenics, the effects on the progeny are negligible. You may or may not see it, and it takes a long time for you to have prominent effects. Whereas eugenics, you will have prominent effects. Euthenics, the effects may or may not be visible. Okay, this is about eugenics versus euthenics. Next, coming to population genetics or Hardy-Weinberg's law. Basically, what this is any allele in a population, any allele of a gene, it tends to remain same from one generation to the next unless there are some external factors. Basically, see, for every gene, you'll have multiple alleles, some A, B, C, D. You'll have different alleles for each gene, right? So some percent of the population will have A, some percent of the population will have B. This frequency tends to remain the same from one generation to another because Mendel said that each allele is passed down from next generation to other. It is a random segregation. Mendel's law of segregation says that only one allele of each gene is passed down to the progeny, and this one allele is completely random. It is not predetermined. So because of random passing on of the alleles from one generation to another, this frequency of the allele remains same. Understood? But let's say there is migration. Let's say some population, the people with population A migrate out of the population, or assortative breeding. That is, the population with only some alleles like A and B, they tend to breed, the remaining don't breed. That is assortative breeding. Selective breeding. Natural selection. One of the alleles is poor in terms of its expression. That is, they cannot survive in the harsh environment and they die off. That is one more. Natural selection. Migration I already told. This should be mutation. Any one of the alleles mutate. So all these external factors can influence the frequency of an allele from appearing. But otherwise, the frequency of the allele, they tend to remain same from one generation to the next. This is Hardy-Weinberg's law. Next is Mendel's law of inheritance. Basically, Mendel gave 3 laws. Law of character units, law of dominance, and law of segregation. Law of character units is all characters, be it phenotypic character, genotypic character, whatever it is, they come in units. And each of these units are controlled by genes. Basically, genes control each and every one's characters. That is law of character units. Law of dominance, each gene has 2 alleles. One dominant allele and one recessive allele. Understood? That is law of dominance, and the dominant allele obviously will dominate over the recessive allele. Law of segregation is only one allele is passed down to the progeny, that is either the recessive allele or the dominant allele, or sometimes you can have both dominant alleles or both recessive alleles, or one dominant, one recessive. But this segregation, they segregate and they're passed down to the progeny completely random, and only one allele is passed down from parent. That is, a progeny gets one allele of a gene from the mother and one allele of the gene from the father. That is law of segregation. These are the 3 Mendel laws of inheritance: law of character units, law of dominance, and law of segregation. Next, coming to genetic disorders, basically, you can have chromosomal disorders like autosomal disorders, Down syndrome, Patau syndrome, trisomy, etc. Sex chromosomal disorders like XO, Turner syndrome, XX, White, Klinefelter syndrome, XXX syndrome. All these are sex chromosomal disorders. You can have Mendelian disorders, which are unifactorial, concerned with only one allele or only one gene, autosomal dominant disorders like Marfan syndrome, autosomal recessive disorders like phenylketonuria, X-linked dominant disorders like vitamin D resistance rickets, X-linked recessive disorders like hemophilia. So these are all the unifactorial Mendelian disorders. Multifactorial disorders are when disorders are controlled by multiple different genes. Many multiple genetic factors influence the see, we don't have a pinpoint gene for diabetes. We don't say, okay, this gene or this mutation causes diabetes. There are multiple genetic factors which influence diabetes, cardiovascular disease, and cancer. So this is the broad classification. This is it for genetics and health. Thank you for watching.